Hello, good morning. I'm discussing about preparation of methods on nanopart materials. There are different ways of classifying the synthesis routes for nanomaterials. The most popular way of classifying the preparation methods is based on bottom-up and top-down approach preparation methods. Top-down approach. Top-down approach refers to slicing or successive cutting of bulk materials to get nano-sized particles. Just opposite the bottom-up approach, it refers to the build-up of materials from bottom atom by atom, molecule by molecule, or cluster by cluster. Nanomaterials is obtained starting from the atomic or molecular precursors and gradually assembling it until the desired structure is formed. This is the top-down approach. That's a bulk materials is break down into powder. Powder is break down into nanoparticles. Again, break down into clusters and into atoms or molecules. In case of bottom-up, just the opposite. The atoms or molecules are synthesized into clusters, and so clusters are joined into nanoparticles, which is again synthesized into powder and also again synthesized into bulk material. It is the bottom-up approach. See, top-down method and bottom-up method. This is the bulk. Bulk is breakdown into powders, and which again break down into nanoparticles. And this also nanoparticles can also break down into clusters, also into atoms or molecular form. And just opposite, in the case of bottom-up, the atoms or molecules join together into clusters form, and cluster is synthesized into nanoparticles, and again synthesized into powder. This is again synthesized into bulk material in case of bottom-up approach. Difference between bottom-up and top-down approach. In case of bottom-up, the starting materials, atoms, molecules, or small clusters. But in case of top-down, starting material is the bulk material. Driving force, low-range forces, van der Waals forces, gives energy minimization, mechanical, electrical, chemical energy for particle size reduction in case of top-down approach. Size distribution, relatively homogeneous allows size in shape control protocols used in bottom-up approach. In case of top-down, mostly heterogeneous, hard to control shape and size. Scale synthesis, usually small scale in the bottom-up. In case of top-down, large scale. The methods, homogeneous and heterogeneous nucleation. Okay, homogeneous and heterogeneous nucleation, chemical or electrochemical precipitation, vapor diffusion, spray pyrolysis, microemulsions used in case of bottom-up approach. But in case of the top-down approach, grinding, dissociation, milling methods are used in case of top-down approach. It's all about preparation methods of nanoparticles according to top-down approach and bottom-up approach. Thanks for watching. Thank you for your patience. It's now bye-bye. See you again.